Hello everyone and welcome to another video. In my last video, we saw how to track Amazon products and notify ourselves whenever the price was lower than a desired price. We used Python Selenium to web scrape Amazon.com and extract some product information we needed for tracking and notification purposes. Today we're going to expand that idea and track multiple products at once. We're going to use a similar approach, but instead we're going to scrape the products listed within a product category. This is the second video of this series, and we'll reuse some of the code we wrote last time. So make sure you go through that one first so you can follow along in this one. Okay, so in this script, I'm importing WebDriver from Selenium, options for the Chrome WebDriver, and HTML from requests HTML. I've also defined the main module, initiate the Chrome WebDriver. And I also kept and renamed the script product function from the last video. Now let's define categories as an array of strings, and in here we'll define the category URLs we want to track products from. So let me switch to Chrome and search for Amazon bestsellers, and here's a list of all the bestseller categories and a few items per category, right? So let's click on the first one, toys and games, and in here we see another list of items for that category, so full list of items with the price tag, customer ratings, and a redirection URL to the actual product page. So the idea is to extract all the product links within this page, and to do that we'll grab the categories URL and paste it in our array. You can add as many categories as you want. And we'll be looping through that array with for category in categories, driver get, category. Now let's define the body element of the page with driver, find element by CSS selector, body. Then HTML string as body element get attribute inner HTML, and with that we'll have the HTML definition. And finally let's define HTML object as HTML, and inside the parentheses HTML equals HTML string. Again, the idea here is to extract all the product links from this HTML object, iterate over them, and navigate to that product link and extract the information we need using the script product function we used in the previous video. And the best way to retrieve these links is by calling HTML object.links, which returns a Python set of URLs, so actually we can iterate over them. Okay, we get all the links within that page. There's few partial URLs that start with a slash. Some of them are actual products, some of them are product reviews. There's links to third-party websites and so on. Since we want to scrape only the links that are actual products, valid products, first we need to clean up this list so we do the scraping efficiently. To start with, let's skip just the ones that start with slash to narrow down the options. So let me define product links as an array, and I'll say link for each link within HTML object.links, which is the object we were just using, if the link starts with slash. This is a neat way to populate an array using list comprehension. If you're not familiar with this concept, this line right here is equivalent to for link in HTML object links, if the link starts with slash, append the link to product links, and we would need to define product links as an array at the top. As you see, it's a one-liner and it's much neater. Okay, let's remove this. Similarly, since these are partial URLs, let's complete them and include Amazon.com upfront as well, using the same approach. So product links equals an array of f-string, https www.amazon.com, then link, we don't need the slash, for link in product links. Let's print them again and see how they look like. Okay, now we can start scraping these pages. But first, let me import time library and add a time sleep function inside scrape product. For instance, we'll say time sleep 0.5, half a second. And we want to do that because since we're going to be scraping many URLs, we want it to be nice to Amazon servers and try not to request them all at once. So we just try to mimic what our end user would be doing, even though that half a second, it's not really human-like behavior, but you know what I mean. Now for each link in product links, we can say product data equals script product link. Let's run it. And we get an error. Okay, if we check this URL, we see that it's actually a login page, so there's no product information, therefore we cannot scrape the product price tag. And this is expected. So what we can do is to add a try block. So say try, scrape function, except pass. So let me define as well product data title none and price none. Initiate those in case we don't find it. And then print out the product price and product data. And let's print the link as well. Let's run it again. It's going to take a while since we have the timeslink function, so let me skip forward in time to see the results. Okay, so I think I'm printing the links twice, but anyways, we see there's a link for the registry, a link for product review. This one right here seems to be a valid product, but yeah, there's lots of them that are not. Actually, see, this one right here seems to be a valid product, judging by the URL, but it has no price tag, so the price is none. Let me open that up. And yeah, right, there's no product tag in here. So in short, Amazon products can have a unique price, they can have a bunch of sellers, so there's no actual price tag in this URL, but various price tags in a secondary URL, or they can be out of stock as well. So we could definitely improve our script product function for all these use cases. For instance, for this one, we could say if we see this message right here, get this link, open it up, and then, I don't know, get the minimum price among all these prices, right? But for the time being, let's keep it as it is. So now that we have added the try block, we don't get any errors anymore. But still, this is not efficient. We don't want to spend time trying to scrape a link that is not a valid product. So now we'll use regular expressions. Basically, we'll build a logic to describe how a product URL looks like, and then we'll try to match all these links against that pattern. See if we get a match. So if we take a closer look, first we have a base URL, then there's what is called a slug, a short product name or product description. Then there's DP for detailed product, usually. And finally, there's the product ID, which is unique for each product. Okay, let me grab these two and paste them in. Oops, let me remove this. Okay, so as a recap, we first have a base URL, then a slug, then DP, and finally product ID, right? So let's define RE pattern for regular expression as an R string that starts with https www.amazon.com, because we set it that way up here. Then the slug pattern, then DP, and finally the product bit, so the product pattern. We can make these patterns as complete as we want, but if we take a quick look at the URLs, we see that, for instance, slug can be random text of any length formed by uppercase and lowercase letters, and it can also contain hyphens. So let's say check for a pattern, call it slug, and then the pattern should match a \W for word. It can also contain hyphens, and it can be of any length. So this pattern will try to match any alphanumeric text, this W, with hyphens. You can check out other patterns using this resource right here. And we'll do the same for the product IDs pattern. To work with regular expressions, we must import RE library at the top of our script. And then we need to actually compile this regular expression with RE compile and then the pattern. Then I can write match as regex.match. And in here, I need to pass in the URL or link I want to check this pattern against. So let me grab a valid URL. Let's grab this one, for instance, and paste it in. Let me define test URL equals this link and use it in my match. Let me comment this out. And actually, we don't need to scrape all the products. which will take a while. So let me move this bit of code above and comment out the loop as well. Now let's print match and run the script. And we see that we get a match. Nice. We can actually access the slug and product ID values that we've defined in between these angle brackets using match product ID and match slug. Let's run it again. See, we retrieve the product ID and the slug text. Now, just for testing purposes, let me add some random characters inside the slug pattern that are not captured within this W. Remember, only alphanumeric characters. Let's run it again. See, we get none. There was no match. Good. So that's some basics on regular expressions. If this is interesting to you, definitely check out more on them. They're really powerful. Okay guys, I've checked a few of the links and I've added a couple of regular expressions. So instead of using just a single pattern, we'll be trying to match each of the product links against various patterns. This is the one we've just seen with the product ID and a slug. Then there's also some links that do not have a slug, so we'll just try to match them against a product ID. And finally, there's some products that do not have slug and have GP for general product instead of DP. So now what we can do is iterate over these patterns. So I'll say for regex option in regex options, we're gonna compile the regex option and try to get a match for these links. So we can as well capture this into a new function. I'm gonna call it get product ID because we've seen we can retrieve the slug and product ID values, but I'm mostly interested in the product ID only from URL. I'll paste the code and we just need to change test URL to URL and pass URL as a parameter. Actually, the regex options array doesn't need to be inside the function, so let me put them as outside. And finally, inside the loop, we'll write if there's a match, product ID equals match product ID, except pass, and we'll return product ID. In case there's no match, we need to return something, otherwise we'll get an error, so we'll define product ID equals none up here. And that's it for this function. So let's scroll down a bit. We don't need these tests anymore, and I'm gonna uncomment this loop. Now we can try to clean up these links up here even more using the same logic as before. So we'll say product links equals an array, and inside the array I'll say link for every link in product links if get product ID from URL link exists. So in short, if we get a match, given the regular expressions, we'll append it to the list. Otherwise, we're not gonna do it. Actually, let's do something smarter. Instead of just returning the product links, let's append to the array as well the product ID. So we'll append a JSON object, and the JSON object is gonna be formed by product ID, and the value get product ID from URL, and then URL is going to be link for every link in product links if the product ID exists. So again, we're using list comprehensions, but we are appending a JSON object instead of just the product link. And since this is not links only anymore, I'm also gonna rename this array to products. Okay, let's see what we've got. Let me comment the scraping loop and let's write for p in products, print the product. Awesome, we see all the product IDs and as well the product URLs. Great. Okay, so the links cleanup using regular expressions should be working right now. And just to give you a sense of what we've accomplished, let's print the length of both arrays, so product links and products. See, we've reduced the links that we are gonna end up scraping from 201 to 50. We have reduced by a factor of 4 the amount of scraping operations we would have been doing in the first place without the cleanup. And that is just for one category. So now we can say with confidence that we can extract all or most of the product links within a category in a really efficient way. So now let's scrape the products and get their title and price as well. Let's capture what we've done before in a new function, and I'm gonna call it scrape category. We'll need products as an argument, and we'll loop for each product in the array. We're gonna scrape that product and return product data. Actually, let's change it and return as well a JSON object as we did for the scrape product function. So in product data, we are scraping the price and title. And from this variable, from products, we have the product URL and product ID. So let's initiate product URL equals product URL and product ID equals product ID. I can also define the final scrape data up here as well. And instead of returning a JSON, we'll append these 4 values inside scrape data in each of the iterations inside the loop. So let's keep it consistent and write product URL, product ID, product price is product data price, and finally product title is product data key title. I want to append a couple of things as well. I want to append the category information, so we can return something like category name, but we need to update a bit the categories array, the first one. So instead of it being an array of strings, it's going to be an array of objects with name. This one is toys and games, and URL, this URL. We need to update as well how we iterate over this array. So now the driver is going to get category URL. And now we are safe to use it in our scrape category function. Sorry, I mistyped category. Cool. Finally, we want to return as well the timestamp of this operation. So as a recap, our end goal here is to track these products and actually see a change in the product price over time, right? So we need this time variable. So let me import datetime, and in script data, we'll append as well timestamp as datetime.now.timestamp. And all that is left to do in this function is to return script data at the end of the loop. Okay, cool. So now within our script, we can say final data equals script category products. And since we are returning a JSON object, let's also import JSON at the top of our script and get it printed nicely. So we'll use print JSON dumps final data sort keys true and with indentation. Let's run it again. Here we have our script data with all the information we needed for our tracking. The category name, the product ID, the product price, the product title, and the product URL, and the timestamp as well. Great. Lastly, before wrapping up, I want to save this data somewhere. So I'll import pandas as PD. And down here, I'll define final data frame equals PD.dataframe final data. Once we have this data frame, we can call final data frame to CSV file. I'll call the file categories.csv, and I won't be storing the index. So let's run it for the last time. And here there is our CSV file. Great. Let me open the file in Excel. And here's all the data that we've scraped. So with this approach, you can basically keep track of the product IDs within a category and check how the product prices change over time. Okay guys, that was it for today. I hope you have enjoyed this second video of the Amazon price tracking series. We've expanded what we did in the previous video, and now we are tracking multiple products at once and saving that information locally. If you already haven't, please subscribe to the channel, give this video a like, and hit the ring bell to receive a notification every time I upload new content. Thanks for watching, and I'll see you in another video.